Okay, good evening, children. Good evening, Deepthi.
Good evening, ma'am.
Yeah, Deepthi, this is the first question. We're not writing anything in today's class, children. Yeah, answer this. Write all the prime numbers less than 15. Anybody can answer. Just tell the answer. Yeah. Two. So we write like this, right? The prime numbers. The prime numbers less than 15. Less than 15 are, yeah, are 2, 2, 3, 5, 7, 11, and 13. Correct? And 13. Correct? Correct? 2, 3, 5, 7, 11, and 13. Okay, are the prime numbers less than 15? Huh? The prime numbers less than 15 are. Thirteen only I've written. Okay. What is the sum of any two odd numbers? What will be the sum of any two odd numbers? Take two odd numbers and find their sum. Even number. Take any two. Yeah.
Ma'am, 5 and 7, answer will be 12.
What is the sum of two odd numbers? 5 plus 7 is?
12.
12. And what is 12? Even or odd?
Ma'am, even.
Even. And what about the sum of two even numbers?
Ma'am, 2 and 6, which is 10, which is also an even number.
Yeah. Now take examples to understand this, children. Now supposing we consider two even numbers 6 and 4. 6 and 4. 6 plus 4, 10. 10 is even. Now consider the even numbers 4 and whatever 8. 4 and 8. 4 plus 8, 12. 12 is even. The sum of two even numbers, yeah.
Ma'am, so the sum of any two odd numbers is an even number, and the sum of any two even numbers is an even number.
Is also an even number. It will always be odd. Okay. So children, the sum of any two odd numbers is always odd. You must, sorry, is always even. You must say is always even. The sum of two odd numbers is always even, or is always an even number. If you want to write, if you want to use the word number also, then you should say is always an even number. Even number. Next. You don't have to give examples. Or the sum of any two odd numbers is always an even number. Yeah, what's it out there? Or why? Why? Huh. Oh, instead of ISS. No. But the result is only one number, right? So you should not say R, ARE. The sum of any two odd numbers. It's not R because the answer is only one, no? So it's always an even number. The sum of any two even numbers is always an even number. Tanya, give an example where the sum of two even numbers is even. 2 plus 2 is 4. Some other example. Okay. So the sum of any two even numbers is always an even number. Now this is not asked, but the sum of, what will be the sum of an even number? and an odd number. And an odd number.
Ma'am, it will be an odd number.
Yeah. The sum of an even number and an odd number is always
An odd number.
an odd number. You can take an example to understand this. So supposing 2 plus 3. 2 is an even number. 3 is an odd number. 2 plus 3, 5 is an odd number.
Ma'am, I took the example 6 and 5.
6 and 5. Okay. So 5 is an odd number. 6 is an even number. 5 plus 6 is 11. The result of 11 is an odd number. The sum of an even number and an odd number is always an odd number. Is always an odd number, correct? Okay. Yeah. Write down these statements in your notebook. So this is your work from 7:15 to 7:45. Write down these statements. Deepti, take down. Yeah, Deepti, take down these statements. You can take a screenshot, but anyways, you have to wait till the students here complete writing this. So I think even you can take it down.
Yes, ma'am, I'll write it right now.
Yeah.
Ma'am, I should write this and solve it after I leave the meeting, right?
Yeah, correct. Take down the statements now. Yeah, you'll answer it later.
I'll just write work after class.
Yeah. Oh, very nice. Okay. Yeah. You should give an example. You must always give an example. When you say true, false, wherever possible, you must give an example.
So if it's false also, you have to give an example. True also, you have to give an example.
Yeah, no, you are going to decide if it is true or false only after taking the example, right?
Yes, ma'am. So we have to write down the example.
You're going to judge the statement only through the example. So yes, example comes first. Example you will take first. Then based on the answer, you will judge the solution true or false.
Yes, ma'am.
Yeah, so example comes first. So you have to write in the example for wherever possible.
Yes, ma'am.
Yeah.
Ma'am, so
now for example, if the statement is 16 an even number, you can't give an example for that. If the statement is 16 an even number, you can only say yes, true, false, right?
Yes, ma'am, we cannot give an example for that.
Yeah. So only give examples wherever possible. Yeah, quickly write down the statements, children.
Ma'am, like all prime numbers are odd. Like for this question, we cannot give an example. We just have to write true or false.
Yeah, correct.
Yes, ma'am.
You have it? Whatever you have, you give. The other one I'll pick later. Write down first. Oh, I'm just finding the message. Yeah, yeah. Yeah, thank you. Yeah, okay. Subtraction. Sorry? Okay. Can I connect tomorrow and teach you then on Teams? I'll do that. Oh, you have half working day tomorrow. Yeah, okay, fine. Finish writing? No. Finish writing? Done? Ovia? Oh, she started this? She finished in teachers? Okay, see, Tanya's finished writing. She's waiting for us. Yeah. Deepthi finished writing?
Mom, almost, Mom. I'm in H.
No, right work was there. Below you just show below you show the examples. Don't squeeze it in the middle. Below, after all the statements. Yeah, just give examples there. Just give examples there. Don't squeeze it between the statements. Against the statements, just say true, false. Write the example there. Yeah, correct. After the statements, don't squeeze it in the middle. Where are you, Satakshi? I was talking to you. Which one? Last, huh? Oh, not bad. நீ கொஞ்சம் சத்தமா பேசுனா எனக்கு கேட்கும். Yeah. Yeah. So Tanya, what are even numbers? Numbers that are divisible by 2 are called even numbers. Satakshi, odd numbers? That means it's correct, but that means it's not divisible by 2. Okay, numbers that are not divisible by 2 are called odd numbers. Deepthi, what are prime numbers?
Ma'am, prime numbers are numbers which have only the factor 1 and themselves.
Factors does a prime number, will a prime number have?
Ma'am?
How many factors will a prime number have?
Ma'am, 2.
Huh?
Ma'am, 2.
2. A prime number has exactly 2 factors. Exactly 2. Always, every prime number will have only 2 factors. 1 and the number itself. What is the composite number, Santosh? Which has more than 2 factors. Okay, a composite number is a number that has more than 2 factors. Very good. Yeah, and is 1 a prime number? No. Is 1 a prime number? Is 1 a composite number? Then what do you call 1? It's a unique number. 1 is a unique number. It's neither prime nor composite. 1 is neither a prime number nor a composite number because it does not satisfy the definition of a prime number or a composite number. If 1 should be a prime number, it should have 2 factors. It has only 1 factor, that is itself. And if it should be, it's not a prime number, so it cannot be a composite number because prime number, 2 factors, composite number, more than 2 factors. So the number 1 has only 1 factor, that is 1 itself. Since it does not satisfy the definition of a prime number or a composite number, it is neither prime nor composite. So 1 is a unique number. It is an odd number. 1 is an odd number. It is a natural number. It is a whole number. 1 is a whole number. 1 is a natural number. 1 is an odd number. 1 is not a prime number. 1 is not a composite number. 1 is a unique number. Okay.
Ma'am, we are doing question number 3 in class.
No. That's what certain things are omitted from your syllabus. That's why I'm just selecting now. Yeah. Do this one. Take down this question, children.
Ma'am, can I see the answer?
Yeah, let all of us finish it, okay? Then maybe when you read out, when you announce the answers, the others also can check it. Complete it in your book and then read out the answers. Huh? Oh, yeah. Fine. Presentation is your wish, yes.
Ma'am, I'm done.
Yeah. Yeah, read out prime numbers.
Yes, ma'am. Prime numbers less than 20 are 2, 3, 5, 7, 11, 13, 17, and 19.
Correct. Very good. Yes, Tanya, composite numbers less than 20. 4. No, 1 minute. 4, 8. Huh? I didn't hear 6 from you. Okay. 4. 1 minute. 4. 6. What about 9? 9. 9, 10. Okay. Then 12, 14, 15, 16, 18. No, 18 and 20. And 18, because less than 20. You have to write the composite numbers less than 20. So you should not take 20 into consideration. So, and 18. And 18. Got the same thing, Deepthi?
Yes, ma'am.
Okay. Correct? Now, I haven't discussed the concept of co-prime numbers. Let me tell you that now. Co-prime numbers. Let's understand, before answering this question, question number 5, let us understand what are co-prime numbers. You checked your answer, Ovia? Yeah, 1 minute, 1 minute. Okay. No, I have not explained.
Find the answer and co-prime like that.
Okay, so what are co-prime numbers? 2 numbers. See, actually it is 2 or more numbers, but we in 6th standard will talk only about 2 numbers. 2 numbers are said to be co-prime if their highest common factor is 1. They will have many factors, but their highest common factor will be 1. Let me take some examples. So now let's consider the numbers. Consider the numbers. Say 12 and 25. 12 and 25. All right. Okay. Let's find the factors of 12. How do you find the factors of 12? 1 into 12, 2 into 6, 3 into 4, 4 into 3. Can you recall this method? 1 into 12 is 12, 2, 6. See, first we start with the tables of 1, 1 into 12, then tables of 2, 2 into 6, tables of 3, 3 into 4, tables of 4, 4 into 3. And we stop here because 3 into 4, 4 into 3. We have got the same pair in the reverse order. We have got the same pair of numbers in the reverse order. 3 into 4, 4 into 3. So stop here. So the factors of 12 are 1, 2, 3, 4, 6, and 12. All right, children. Now for 25. So it's going to be for 25, 1 into 25 is 25, It's not divisible by 2. It's not divisible by 3. It's not divisible by 4. So by 5, 5 into 5. And after this, you know, it doesn't happen in any other table. 1 minute, 1 minute. Sorry? 1 into 25, we've already written. Then 5 into 5. After that, it's going to be only 25 into 1. Because I've told you, when you get the same pair in the reverse order, you must stop. So you will not get anything. So finally, it will be in the tables of 21. You start from 1 and you should go up to, you will always start from 1 and go up to the tables of that number itself. Like from 1 to 25 or from 1 to 12. See, you should write 1 into 12 is 12, 2 into what, 3 into what, 4 into what, 5 into what, like that. But when you encounter a pair in the reverse order, you stop there. Am I clear, children? Now for 25, 1 into 25, then 5 into 5. Then you will not, 25 does not happen in any other multiplication table. So you will keep going, and then finally you will get 25 tables, 25 ones are 25. So now cross this. Because 1 into 25, 25 into 1. So the factors of 25 are 1, 5, don't repeat. 1, 5 and 25. 1, 5 and 25. And 25. Okay. So now what are the common factors of 12 and 25? Common factors. Common factors. Common factor of 12 and 25 is 1. Is 1. Therefore, HCF of 12 and 25 is 1. Therefore, this means
it's a co-prime number.
This means 12 and 25. 12 and 25 are co-prime numbers. Are co-prime numbers. For same procedure. You should find the factors of all the 3 numbers and all of them should have only 1 in common. Nothing other than 1. Same procedure. But for your standard, it will only be for 2 numbers, not more than 2 numbers. So consider, okay, sorry, you understood this now. So write the factors of the given numbers. The numbers are 12 and 25. Write the factors of 12, write the factors of 25. And see the common factors. So here only 1 is common between 12 and 25. The factor 1 is only the factor 1 is common between 12 and 25. Which means the highest common factor itself is 1. Supposing they had, like, say, supposing they had 1 and 6 in common, then the highest common factor is 6. Supposing the 2 numbers, supposing they had 1 and 6 in common, that means the HCF is 6. But now what is common? 1. So the HCF is also 1. So if the HCF of 2 numbers is 1, then they are said to be co-prime numbers. Now, but look at the numbers. Is 12 a prime number? No. Is 25 a prime number? No. But 12 and 25 are co-prime numbers. So co-prime numbers need not be prime numbers. 2 numbers which are co-prime need not be prime numbers. They may not be. 1 may be prime, 1 may be composite, or both may be prime numbers, both may be composite numbers. Just because the term is co-prime numbers, it doesn't mean that the 2 numbers have to be prime numbers. They may or may not be prime numbers. There may be a combination of a prime number and a composite number also. Okay, so is 12 a prime number? No. Is 25 a prime number? No. But 12 and 25 are co-prime numbers because their HCF is 1. They are co-prime. Always. Any combination of a prime number. No, not every. No. You can give an example of a prime number and a composite number which are co-prime, but not that every combination will be co-prime. They are, yeah. 2 prime numbers are always co-prime. 2 prime numbers will always be co-prime, but a prime number and a composite number, like for example, 13 is a prime number, correct? 13 is a prime number. 26 is a composite number. Now the factors of 13 are 1 and 13 itself. The factors of 26 are 1, 2, 13 and 26. 1, 2, 13 and 26. So the HCF is 13. See, 13 is a prime number, while 26 is a composite number. The factors of 13 are 1 and 13 itself because it's a prime number, while the factors of 26 are 1, 2, 13 and 26. The two numbers have 1 and 13 in common, and the HCF is 13. And the HCF is 13. So the 13 and 26 is a combination of a prime number and a composite number. 13 and 26 is an example of a combination of a prime number and a composite number, but they are not co-prime. They may be, some combinations may be co-prime, not all the combinations. So if the combination is both prime, if both are prime, they are co-prime. If both the numbers are prime numbers, then they will be co-prime. If both the numbers are prime numbers, then they will be co-prime. But if it's a combination of a prime number and a composite number, or two composite numbers, they may or may not be co-prime. When are they always co-prime? Prime and prime combination. Prime and prime combination, they're always co-prime. Any other combination, they may be, they may not be. Write down this, children, from co-prime numbers. Please write down from co-prime numbers.
Ma'am, will we be learning about twin primes?
Louder, Deepti.
Ma'am, will we be learning about twin primes?
No, not in your syllabus.
Ma'am, but our teacher has taught twin primes.
Okay, then maybe next concept I'll do that. You write down this, next I'll teach you twin prime numbers.
Yes. Ma'am, actually twin primes is not in our textbook, but ma'am has taught it.
Yeah, we can do. We'll do. Don't worry. Write down. Done the slide, children?
Ma'am, 1 minute, ma'am.
Okay. Okay, fine. I'll teach you alone tomorrow.
Done, ma'am.
Yeah. Please take down this example.
Excuse me, ma'am.
Yeah.
Ma'am, can I add the point that 12 and 25 are composite numbers?
Yeah, you can mention that they're a pair of composite numbers which are co-prime numbers also. Yeah. Then writing children finished. Then writing children.
Ma'am, I have written 12 and 25 are a pair of composite numbers which are co-prime numbers.
Very good. Okay. This is the next one, right? Yeah. Yeah, yeah. There are. There are.
Ma'am, I have a doubt. Ma'am, in twin primes, two prime numbers are said to be twin primes if the difference is 2. So
If they differ by 2. If they differ by 2.
Ma'am, so they have to be prime numbers and they have to be differed by 2, right?
Yeah. Co-prime numbers need not be prime numbers, but twin prime numbers have to be prime numbers. That's why the definition 2 prime numbers are said to be twin prime. 2 prime numbers, not any 2 numbers. 2 prime numbers are said to be twin prime if they differ by 2.
Yes, ma'am. And in co-prime numbers, it's okay if one number is composite and one number is prime.
The co-prime numbers can be of any combination. Co-prime numbers can be 2 prime numbers, 2 composite numbers, or a combination of a prime number and a composite number. That is why the definition of a co-prime number is 2 numbers are said to be.
Yes,
Co-prime numbers, the definition is 2 numbers are said to be, not 2 prime numbers, 2 numbers. So the 2 numbers can be a combination of a prime number and a composite number, or they can be both composite, both prime. 2 numbers, any 2 numbers.
Yes.
are said to be co-prime if their HCF is 1. But twin prime numbers are prime numbers. Are prime, two numbers, two prime numbers are said to be twin prime if they differ by 2.
Yes.
So we can see 3 and 5 are prime numbers and they're twin prime because they differ by 2.
Yes, ma'am. And 5 and 7 are also prime numbers.
Okay, yeah. Yes. Okay. So co-prime numbers can be any two numbers. But twin prime numbers have to be two prime numbers. See the definition, twin prime numbers. Two prime numbers are said to be twin prime. So both the numbers must be prime numbers. And two prime numbers are twin prime if they differ by 2. The difference must be 2.
Excuse me, ma'am.
Yeah.
Ma'am, I have sent the picture on WhatsApp of a sum that I was not able to understand.
Mm.
I asked that if you could solve the answer and
After the class, after 9:30 today is fine?
yes, ma'am.
Yeah, I'll send it. Done, children? Okay. Did I mention about perfect numbers? Perfect number? No. We'll just write it again. No, I'm not sure. 1 minute. Just writing. Perfect number. Both. And I'm writing both. You should also write both. Finished? Yeah. Done, children? Now let's take an example. So when you add the number itself, you'll get twice the sum. If you don't add the number, you'll get the number itself. Yeah. Yeah. So it's enough if you write any one. Okay, so I've written both for you. You can write this one or this one. You can write this or this. So see here. Okay, no. Now you have to write both. I'm saying in the exam. Now you have to write both. Now, how do you now supposing you're given this number 6. Is 6 a perfect number? Is 6 a perfect number?
Yes.
So how do we answer that? Yes. How do we answer that question? You need to write the factors of 6. Okay. So the factors of 6 are 1, 2, 3, and 6 itself. All right. Next, exclude the number 6. Add the remaining factors. Exclude the number itself. Add the remaining factors. 1 plus 2 plus 3. What is the result? 6. It's the number. It's a given number. So when the sum of the factors of the number, not including itself, don't include itself, because every number is a factor of itself. every number is a factor of itself. 1 is a factor of every number. 1 is a factor of every number, and every number is a factor of itself. Now, ignore this number 6 itself, the factor 6 itself. 1 plus 2 plus 3 is 6. That is the given number. If you add the factor also, if you add the factor 6 also, that is the number itself, 1 plus 2 plus 3 plus 6 also, then you will get twice the given number. 6 is the given number, you will get 12 as a sum. So you can check any one of the two. If you add all the factors, you must get twice the given number. If you add the factors, if you add the factors, not including the number itself. See here. If you add only these three, 1 plus 2 plus 3, 6 you get the given number. If you add all the 4, you will get twice the given number. That is 2 into 6, 12 as a sum. Here. Then also the prime, it's a perfect number. If you add these factors till 14, then the sum will be 28. But if you add all the factors, that is including 28, then you will get double the answer. 56 you will get. Both is a check for a perfect number. You can check it both the ways. If you add all the factors, you must get twice the given number. You must get 2 times the given number. When you write all the factors, you would have written the number also, right? When you write all the factors, you would have written the given number also, because the number is the factor of itself. So if you add all the factors, the sum will be twice the given number. Supposing you, from the factors, you don't write the number itself. You add the remaining factors. You don't add the number itself. So that means the last factor you don't use. You add the remaining factors. Then you will get the given number itself. This is the check for a perfect number. This is a check for a perfect number. See here, that's the definition. See here. If the sum of all the factors of a number, excluding itself, meaning don't include itself. If the sum of all the factors of a number, excluding the number itself, don't include it, is equal to the number given, is equal to the number, is equal to the given number, then it's called a perfect number. Or if the sum of all the factors of a number, including itself, is equal to twice the number, then it is called a perfect number. Both are fine. If you take the number itself also, then you will get twice the sum. Deepthi, understood that?
Yes, ma'am.
Okay. Yeah, what's it out, Olivia? Here. Yeah, excluding itself. I didn't add the number 6, no. Then the sum will be the given number only. I've added all the factors. You can ask me again, I'll tell you. Yeah. In the first one, I've excluded the factor 6. In the second one, I've included the factor 6. First, we list all the factors. Then while finding the sum, in the first one, I've not included 6. In the second one, I've included 6. Yeah, here itself I've shown both the methods. No, this is not a sum, it's just an explanation. You will be doing only one of this. Supposing you are asked to check, you will do only one of this. I'm just explaining here. So in the first one, I've not included 6. Then the answer is the number 6 itself. In the second one, I've included 6. Then the answer will be 6 into 2, 12. All right. Yeah, answer this one. What is the greatest prime number between 1 and 10? 7. The greatest prime number between 1 and 10 is 7. Correct? Yeah. Express the following as a sum of two odd numbers, odd primes. Yeah, do this thing. Now. Express as a sum of two odd primes. Two odd prime numbers. You must take two prime numbers. Both must be odd. If you add, you must get 44. If you add, you must get 36. Some other two numbers. If you add, you should get 36, like that. Definitely. Same? Okay. Yeah, Satakshi, see, you have to take two prime numbers, two odd prime numbers. And when you find their sum, the answer should be 44. You must take two numbers. Both the numbers must be odd as well as prime. Both the numbers must be odd and prime. That's why two odd primes. Odd primes, meaning odd number and prime number. If you add, you must get 44. So B. What's your answer for A? 31 plus 13. Very good. 13 plus 31. 31 plus 13. Very good. Yes, Tanya. Second. 31 plus 5. Very good. 31 plus 5. Yes.
No, answer the question. Wait, what is your answer? That's
Yeah, you are right.
it's not. Wait. 19 plus 5.
Very good. 19 plus 5. 18.
18. Wait. So, 17. Not 13 plus 13 plus 5.
Okay, also. One more. Yeah, correct. We wrote all the prime numbers till 100 the other day. We listed all the prime numbers less than 100 in the class the other day. Maybe you must. No problem. Recall. We did write all the prime numbers less than 100 in one class. It's in your book. Or if you missed one class, you missed, no? So Eratosthenes, C. Yeah.
Ma'am, I already know all the prime numbers with less than 100.
Yeah. What come again, Deepti?
Ma'am, I know all the prime numbers less than 100 without
Very
seeing.
good. Very good. Okay. Done this one, Deepti?
Yes, ma'am, I'm done.
Yeah. Sorry? Oh, that method, huh? Okay, very good. Yeah. What's the next question? This is the next question, children. Please try this.
We can use the number again and again, same number.
If possible, use 3 different numbers. If not possible, you can repeat it. But you can use 3 different numbers.
But I use 8 to them. Okay. 13 plus 5 plus 3.
3 plus 5 plus 13. Okay, now 1 minute. Let all of us try. Yeah. Let for the first one, huh? Yeah. But when it's possible using 3 different numbers, we have to do that. But your things, I appreciate what you said.
Okay. Seven for 31. 7 plus 7 plus 7. Plus 3 plus 7. 4 7 4 7 plus 7 4 8 9 13.
Yeah. Deepthi, first one.
Mom, the first one is 3 plus 5 plus 13.
3 plus 5 plus 13. Very good. Yeah. Anybody here? Second one? Yeah.
7 plus 7 plus 7 plus
31.
Yeah. 7 plus 7 is 14. 14 plus 7 is 2.
No, use different numbers. And you must use only 3 numbers, not 4 numbers.
Mom, may I say?
Oh.
Yeah, Deepthi?
Mom, 3 plus 5 plus 23. Oh, sorry, Mom. Yeah, that 3 plus 5 plus 23.
Yeah. Fourth C, is it? Ah. (23 plus 3 plus? 23 plus 3 plus 3 is 29. (53), next one, 53. For
23 plus 19 plus 11.
23 plus
10.
11 or 7?
1.
Correct.
Mom, for 53, I have written a different answer.
Yeah, tell me.
Mom, 7 plus 17 plus 29.
7 plus?
17 plus 29.
Very good. Correct. 2 you should not use. 3 odd primes. Should not use. One second. Yes, Satakshi, sorry. No teacher will say that. No, sometimes you might have not understood that correctly. Yeah. No. Yeah, Deepthi?
Mom, I have written 31 plus 19 plus 11. Yes, ma'am.
Correct. Very good. Any other answer here?
Just like this. 23 minus 1 that answer. So I asked those to be what answer.
Finished? All of you? No, we are not doing this now. 1 minute. All of you find the HCF and LCM of. Find the HCF and LCM of 8, 15 and 30. Not 30, 1 second, and 25. We'll do one sum together. The next sum you can try it by yourself. Now let's do this one together. Let's first find the HCF. Okay, let's find the HCF. So yeah. No, children, help me. No, please help me. Tell me for HCF, just for the HCF. So for HCF, children, you need to take a number which divides all the numbers, correct? Which divides all the numbers. Is there any number that divides all the 3 numbers?
5. You can use 5. But 8, what satisfied? We can
For
take
HCF?
number instead.
No, you should take only prime numbers. You must take a prime number that divides all the numbers. 2 doesn't divide 15 and 25. Doesn't divide 25 and 8. No. So from this itself, we can make out that the HCF of the 3 numbers is 1.
Yes, because nothing divides 8, 15, and 25.
Sorry, Deepthi?
Mom, because no number divides 8, 15, and 25.
All the 3 numbers at the same time. Yeah, there is no number that divides all the 3 numbers at the same time. So which means the HCF of these 3 numbers is 1. Correct? So we will not use this method. This method you cannot, because there's no number that divides all the 3 numbers. Then let's list the factors. What are the factors of 8? 3 methods are there. Factor 3 method, prime factorization method. Yeah, what are the factors of 8? 2. What about 1? 1 into 8, 2 into 4, 4 into 2. Factors of 8 are 1, 2, 4, and 8. What are the factors of 15? 1 into 15 is 15. 3 5s are 15. 5 3s are 15. So 1, 3, 5, and 15. And what about 25? Factors of 25 are 1, 5, and 25. Because 25 is 1 into 25, 5 into 5, and 25 into 1. So what's the common factor? What are the common factors?
Mom, 1.
Yeah, common factor of 8, 15, and 25 is 1. Therefore, HCF of 8, 5, sorry, 15 and 25, 8, 15, and 25. Yes, Saptakshi. Yeah. You know how to list the multiples and find the LCM, right? Listing the multiples. Multiples of 8 are 8, 16, 24, 32, and on. Multiples of 15, then multiples of 25. So that's lengthy, but you know the method, right? So we'll do this method for LCM. Okay, so HCF, sorry, LCM. You want me to show the earlier slide, children? Okay. Yeah.
What's the one? 3 for
8, 15, and 25.
3.
You should start with the least prime. 2. 2 fours. 2 fours are. To find the LCM, you can take a prime number that divides at least one of them.
Yes, Mom. Mom, it'll be
At
4,
least.
15, and 25.
Yeah, it need not divide all. At least one of them. So 2. 2 fours are, write the other numbers as they are. Because they're not divisible by 2. Again take 2. Again take 2.
Mom, again 2.
Again 2.
Mom, then 5.
Then?
5.
No, 3. Now
Yes,
5.
3, then
Now
5.
5.
And then 5 again.
Okay, I'll tell you one thing. I'll not answer that. You do that. Let's see what happens. No, you please do that.
Yeah.
Yeah, you. It's fine. You just do with what you feel like.
Mom, may I tell the product of this?
Yeah.
I'm 600.
Okay, very good. What happened, Ovia, when you did that? Okay, then next. 3 you took, no? That's what I took in the order. And you, all of us will get the same thing. So I normally do in the order. Even if you take 5, without taking, before you take 3, if you take 5, then later down you will get 3. You will have to use 3. So I normally go in the order. I try with 2, then 3, then 5.
Mom, actually in the step when it came 1, 15, and 25, I have taken 5. But then at the end, it became 1, 3, and 5, and I cannot divide them both. So it was 2 into 2 into 2 into 5 into 5 into 3 into 1.
Okay. 1, from where do you get 1?
Mom, like 1 comes down because 15.
No, you don't have to write that. Okay, but you don't have to write any of these
I have not
numbers.
written multiplied by 1, but 1 is there.
Okay. 600, correct? Okay, so now take down these questions. Okay, this we'll do it orally, no? What is a number? A number which has only 2 factors is called a prime number. A number which has more than 2 factors is called a composite number. One is neither prime nor composite. One is neither prime nor composite. The smallest prime number is
2.
2. 2 is the smallest prime number. The smallest composite number 4. The smallest even number is
0.
no 2. Yeah, you're right, because zeros, the smallest even number is 0. Sorry, 2. 2. The zeros, no, 0 is also an even number. See, when you come to higher classes, we regard 0 also as an even number because it's not divisible by 2. Sorry, it's divisible by 2. Somebody's come? One. Because it's not, 1 second, 1 second, I was, இல்ல வாங்க வாங்க இல்ல இந்த கிளாஸ் முடிச்சிட்டோம் வெயிட் பண்ணுங்க வந்துட்டேன் yeah 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 Santosh, so 0 because it's divisible by 2, it's called an even number. Yeah, now quickly take down these questions, children. Deepti, please take a screenshot because as you know, I have a class after this, so I need to start that meeting. All right?
Yes, just a minute. I'll just get a phone.
Yeah. Done, Deepti? Finish writing, Tanya? Come here, start. Come here. Start working.
Mom, I'm back. Just a minute. I'll just quickly take a picture.
Yeah. So, the third row there.
Yes,
Yeah.
Mom. Done.
Are you able to get inside or no? No, right? Then come here to the second one. Yeah, get inside.
Hello, Mom.
Yeah. Yes, Deepti? Done?
Mom, I am done taking the picture.
Yeah. You can start working. Done, Deepti?
Yes, Mom.
Yeah. All right, Deepti. So, all right, children, that's it for today's session. Thank you so much. Deepti,
Yes.
you completed? Yeah, I think you should be able to finish it by 7:45. All right?
Yes, Mom.
All right, Deepti. Thank you.
Mom, should I send you a picture of it or will we discuss in next class?
Sorry?
Mom, should I send a picture after
No. I'm still working on. I'm almost done writing the answers to the like the material on this chapter. I'll let you know on WhatsApp. You just complete it. I'll let you know.
Yes, Mom.
Yeah. Okay. Thank you. Bye.
Thank you.
Bye.